Hi, my name's Taylor, and I'm an incoming freshman at Stanford studying computer science. I'm interested in the intersection between AI and ML and health, and I've been working on several projects in this area involving computer vision. I participated in AIMI's first summer research internship, and I'm really excited to learn more from Nish today.
And hi, I'm Sarah. I'm a freshman at MIT studying computer science and math. And so in the summer before my junior year, I met Taylor through working with her at AIMI's first internship program. And I've stayed interested in AI, involved with AIMI since. So yeah, so like Taylor, I'm more than happy and excited to welcome Nish on to today's Gen Talk, Next Gen.
Yeah, to intro Nish, Nish is a leader at the intersection of AI and healthcare. He's the CEO and co-founder of Bunkerhill Health, which is working to streamline AI development and adoption in healthcare.
And additionally, he has done extensive research in AI and ML, working on the validation and translation of medical imaging AI algorithms into clinical practice. And so now we'll hand it off to Nish.
Thanks, Taylor and Sarah. And thanks, Joanna and Michelle. It's so great to be here. Thanks for having me. I wanted to start by just giving a little bit of background about me and then going into more about how I got into the field that I'm currently in, which is translation of AI algorithms from research to clinical practice, what that means and what we do at the company. I was born in India, but I was raised in India and Saudi Arabia and the UAE, and I came to Stanford for undergrad, where really I was planning on studying some combination of computer science, philosophy, and some physics. But when I took my first machine learning class, I got really excited about what that meant. I had never heard of it before. And to someone who was interested in sort of discussing high-level philosophical questions and also applications, machine learning was the perfect intersection of those two, especially during that time in 2015, 2016. I took a bunch of machine learning classes in starting my sophomore year. And what I realized was that a lot of those classes had projects as the final sort of assignment. And doing those projects really let all the students in the class explore what they're interested in and apply machine learning to those domains. And through that effort, I got connected to the AIMI Center. I was then put in touch with a cardiologist at Stanford, and he's a preventive cardiologist. What that means is that he is interested in preventing future heart attacks and future strokes. And so he told me about one of the problems that he was facing, which was when he would see patients in his clinic after they have had a heart attack or a stroke, he would typically look back at that patient's history to really understand what led to the first heart attack to begin with. And usually he would find a CT scan that was collected for some other reason, say like the patient was a part of a car crash 4 or 5 years ago and came to the emergency department at Stanford to really understand what happened to, like, if there are any rib fractures or not. And so, or maybe the patient came in because they had pneumonia and the pulmonologist had ordered a CT scan. And so he would look back at the records and typically he would find a CT scan of the chest. And on looking at that scan, he would see that there were calcium plaques in the arteries, but the patient hadn't been followed up with for care. No one had made sure that the patient, after they've gotten that CT scan 4 or 5 years ago, ended up seeing a cardiologist or ended up getting started on preventive medications. They literally had a heart attack, and only after that did they see a cardiologist. And so in his profession, in his interests of preventing future heart attacks and strokes, he was particularly interested in this opportunity of, could we use AI and machine learning to detect and flag patients who have an increased risk of heart attack or stroke and get them in the clinic when you can actually make a difference to that patient, as opposed to waiting for a heart attack or a stroke. And so I worked with him along with a friend of mine who's now my co-founder. I worked with him to build an algorithm that can do that, which is, can you detect patients who have high risk for cardiovascular disease from scans that are being collected for some other reason? We built an algorithm. It worked well. We published the paper. We made some pretty big claims about how this could really make a significant difference to millions of patients. And to my utter disappointment, that paper is where the algorithm sort of just ended, the journey of that algorithm. And as someone who had joined that project, who had taken that opportunity up because of the potential impact, the potential application of that tool, I was pretty disappointed that really there was no plan or really know-how of how to actually get these tools into clinical practice. Initially, I sort of thought that this is just what happens in academia. You work on something, you publish a paper about it, and then you potentially move on to future projects. But then, as I mentioned earlier, I grew up on the other side of the world. And one day, after this project had happened, I get a call from my mom saying that my dad wasn't waking up. My dad just had a heart attack, and he's fine now, but they rushed him to the emergency center. And when he went there, they found calcium plaques in his arteries. This was just too close to home for me, where I had spent the last several years working on building an algorithm that can do exactly that, which is detect and quantify calcium plaques in the coronary arteries. That sort of professional frustration now combined with personal frustration really had me begging the answer to the question, why was this Stanford algorithm that worked, why was that algorithm not being used at every hospital in the world? Yeah, why was it not even being used at Stanford Hospital, which, owned the IP and could use it for free? It's really frustrating when you sort of are cornered into a position where you have to ask that question. And, this algorithm had massive potential for clinical impact. It had massive impact. It had massive potential to help hospitals even generate more revenue. So, there was a clinical reason for someone to use the algorithm. There's a financial reason for health systems to use the algorithm, yet it was not being used. And what I learned was that sort of outcome for the algorithm that I had worked on was also the same outcome that a lot of my peers were facing as well for their algorithms. This was a common trend or a common pattern that we were seeing where researchers across institutions, and this is not a problem that I uniquely faced by any means, researchers were building different AI algorithms for use cases in healthcare, very cool use cases. And for most of them, the end goal had become, the end state had become a publication. Publications are important, but these tools ultimately need to make it to clinical practice. And so that entire situation forced me to spend a couple of years just trying to understand the answer to the question, how can these AI tools be translated from research to clinical practice? And on a high level, every researcher who works in the field kind of knows the idea of what the steps are, which is, hey, you have built a research algorithm. So step number one is to make sure that this algorithm works well across different patient populations, scanner configurations, disease prevalence. So basically, does your algorithm actually work as expected? The second step would be, you need regulatory clearance. You need to talk to the FDA, get approval and clearance for your algorithm. And then the third step would be to actually deploy the algorithms that you had built into clinical practice. And see, on a high level, all of this made sense. On a high level, all researchers working in the field know about these steps. But the moment you start or try to start working on the steps, you realize, hey, I don't even know where to get started on any of these steps. It is like similar to saying, I know how to get to the moon, like build a rocket ship, get on top of it, press start, and you're already at the moon. The devil was in the details. The devil was really, where do you get started and how efficient or how much friction is there in the process? And so we spun out a company to basically help with that problem, which is how can we get ideas from people's mind, from research to clinical practice as quickly as possible. That's what Bunkerhill Health does. And I'll get into what we do in just a second here. I'll share my screen now. So what we've done at Bunkerhill is we have developed this two-part company. The part on the left that you see is a consortium of academic medical centers. Think of it as a legal bubble, which allows researchers to work with each other across institutions, to share their data with each other, share algorithms with each other. What this allows researchers to do is take their proof of concept algorithms and battle test them across data from multiple hospitals to know if your algorithm actually works as expected. And when the researchers finish building algorithms, so this consortium allows them to work with each other, validate each other's algorithms. And when they're done, when they know that it works well, they can hand off their algorithms to the second part of the company, what you see on the right here, where we file for regulatory clearances and then distribute these algorithms for clinical use across these hospitals. And whatever revenue we then get is then shared between Bunkerhill and the institutions that contributed to the algorithm, those researchers. So, if we work as we expect it to, we will take a potentially vicious cycle and make it a virtuous one. Previously, when researchers built algorithms, they would publish their paper, but they would not necessarily see their algorithms through clinical translation. And what that meant was when they started on their second project, their third, fourth, fifth project, they're starting off with a lot less energy, with a lot less excitement, because they know that the end state for that algorithm is not necessarily clinical deployment, but rather just a publication. So that's a vicious cycle. And hopefully with Bunkerhill, we can make it a virtuous one, where a researcher works on their algorithm. They not only get a publication out, but they actually see their algorithms, see adoption and gain adoption. And that actually gets them even more excited for their second algorithm, for the third, fourth, fifth. And it's an energy additive cycle as opposed to an energy depleting one. And so we hope that this can serve as a way for researchers to preserve their momentum and excitement about their field. The way this works is that if you're a researcher who has an algorithm, you can approach Bunkerhill. We will connect you with hospitals that are already in our network to see if they are interested in giving you data to help improve your algorithm's performance. And what they get in return is that they now get to use your algorithm for free. We will help deploy the algorithm there. Once the training is done, the researcher, you can actually launch a validation study to show that your algorithm performs consistently well across data from multiple hospitals, to show that your algorithm has utility and works really well. And again, these hospitals now get to use that algorithm for free. We take that validation data and apply for FDA clearance. When we receive it, we then distribute the algorithm to other hospitals. And whatever money we make from distributing that algorithm is then shared between us, the researcher who built it, as well as with the hospitals that contributed training data. So today we have 25 hospitals that are part of this research network. And we have 29 algorithms that are at different stages of validation and training and distribution. The way I want to sort of ground this is by sharing a success story of the algorithm that I actually worked on during my time at Stanford. This is the algorithm that I mentioned could have potentially helped my dad. Now, to just quickly recall, this is an algorithm that finds patients in an existing population that have increased risk for heart attacks and strokes, but are unaware of it. And these patients can then be referred to a preventive cardiology clinic to get them started on preventive medications. As I mentioned earlier, this was built at Stanford. The research group then launched a multi-site validation study across a couple of hospitals, including UCSF, and they got a good publication out at the end. They saw that their algorithm performs consistently well. The researchers went a step further and showed that when the algorithm flagged a patient, the patient had a much higher risk of heart attack and stroke and death compared to a patient who was not flagged by the algorithm. They even went a step further and showed that when you do use the algorithm in practice, a lot more patients get started on preventive medications as opposed to patients who were not, as opposed to when the algorithm was not being run. So they did a randomized control trial, which is effectively A/B testing in the clinical world, where in the control arm, in one arm, they showed that when the algorithm was not being used, only 7% of the patients that needed to be on preventive medications were on preventive medications. Whereas when they started using the algorithm, that number jumped to 51%. So it was a 7x improvement. So the researchers did a great job in showing that the algorithm performed well, that it had utility. And as a result of our arrangements, these hospitals are now using it in clinical practice. So at UCSF, this algorithm has now been live for a couple of years now. We have already run it on over 25,000 scans there. And based on the data that was collected by these amazing researchers, we went to the FDA and they gave us clearance for this algorithm. And we've now distributed the algorithm at over 150 sites. And these are some of the centers that are using these algorithms. As you might be familiar with Cleveland Clinic and Mayo Clinic, just some of the finest medical institutions in the world. And here's some real world data. So at Stanford, for every 5,000 scans that we ran the algorithm on, we found 213 additional patients for the cardiologist to treat for those. Then these are 213 patients who were not on the medications that they were supposed to be on and now get started on those. So you're really this algorithm is really doing a fantastic job at lowering the risk of heart attack and stroke. And it's a win-win-win. The researcher is now happy, the research team is now happy that their algorithm is being used, that it's FDA cleared. The hospitals that participated in the validation of it are happily using the algorithm, and plus the researchers, they got a publication out. And the hospitals that are using it in clinical practice are obviously reaping the rewards of using such a tool in practice. Obviously, we are not a company that is just based on one algorithm. We want to do this for all the other algorithms that all researchers are building. And here are some examples of it. You might have one scan, and from that one scan, we could have multiple algorithms detect different conditions that otherwise go missed. So we talked about the first one thus far. The other algorithms could detect things that potentially would aid in saving their lives or extending the quality of their lives. Similarly, from other types of scans. And also, I'll take one particular example that gets me really excited. As many of you might know, women who are about a certain age, I think it's either 40 or 50, I'll need to check, but they are recommended to undergo breast cancer screening every other year. So these women would undergo a mammogram, and based on the mammogram, they would be checked for breast cancer. Now, one of our consortium members has built an algorithm that can detect patients who are at increased cardiovascular risk from these mammograms that are being acquired for screening. So what gets me really excited is that if you deploy an algorithm like this in a nationwide setting, you would have turned a nationwide cancer screening program into a nationwide cardiovascular screening program. And that's a super cool. Yeah, thank you for having me. I would love to answer any questions.
Cool, that was super insightful. So we heard a lot about kind of your process from starting out in computer science to moving into ML research and then to starting a company. So what has that process of starting a company been like? And then what advice would you give to students interested in kind of pursuing that route?
The journey from college to a startup was a pretty blurry one, mostly because I didn't really know, or there wasn't a one single point where we said, hey, we are starting a company. I think based on the kind of person I am, I don't think I could be and this is not a wrong thing. I think there are great companies that have emerged from this, but I'm not the kind of person who could decide, hey, I want to start a company and then search for ideas. I think that works great for a lot of people. It doesn't work for me. For me, this was, I spent about 5 years, 5.5 years at Stanford. And the last 2.5 years, all I did was explore my interests, academic interests. And what I really got hooked to was this problem of translation of AI from research to clinical practice. And so in terms of starting a company around it, we saw that there was an unmet need, and we realized that one of the only ways to attack that problem and fulfill that unmet need would be by starting a company. And then once you've made that sort of, I wouldn't even call it a decision, but more like a realization, everything sort of follows from there. I don't think that there is a class on, maybe at Stanford there might be a class, but like how to start a startup from a legal or a operational standpoint. We just one day decided that, hey, it's not one day, but like we decided that the startup is probably the only route to realize our vision. And we talked to a few investors who were like, this sounds cool. And that's how we, I guess, officially got started. In terms of advice, I don't think I'm at the position yet where my advice actually should matter. But the one thing that I would encourage, or at least holds true for me, is that all advice needs to be associated with context. I feel like there's a lot of advice out there from really wonderful people who have done great, but that advice necessarily applies to them with their context, with their background, and based on who they are as a person. And so the one thing I've learned is that it's really circumstantial, and you just have to think on the fly. You just really have to be confident about the decisions that you make and be willing to be wrong. Everything beyond that is just anyone's guess.
Yeah, and so kind of more on your your process on building a startup, this startup journey. Is there a moment that you would say is like the most pivotal in your career?
I think that moment actually happened before I started the company. After I had that incident of building the algorithm but not seeing it being used, and my dad's heart attack, I sent a almost angry but email to Kurt Langlotz, who actually hosted on the first episode of this series. I didn't know that he was a big deal. I just knew that he would probably know something about this. I sent him a cold email basically saying like, look, I've been working on all of these algorithms, but none of them are being used in clinical practice. Can we do this? And Kurt, being the type of person he is, he actually responded almost immediately and said that this was a wonderful idea and he wanted to meet to discuss that further. Going into the meeting, I didn't have a lot of expectations, but when I left the meeting with my friend, now co-founder, it was obvious that it was a defining moment because he basically just shared all his knowledge with us, and he was super receptive. And that, I guess that's one of the things, like there are people like Kurt who do things that they don't need to do. They take a chance on people, and in some cases, it really changes people's lives. It did in my case.
It's incredible. More on like the process of developing your company. How did you get so many hospitals to agree to use your system? And kind of how did you establish that network?
Cold email. Just do cold emails. You need one positive response to get started. It did help that I had done quite a bit of research at Stanford on this. And so that sort of pedigree and past experience, I don't even know what past experience in AI for medical imaging is, but whatever that is, that definitely, like, we just cold emailed a bunch of hospitals. It's just, you have to put yourself out there.
Right. And kind of along those lines, say you have like a really good idea, you're thinking about, are there any resources or services that Bunkerhill Health could provide? And how do you really like identify a good idea, and how do they identify you as a resource?
Two very different questions. I'll take the first one and then the second one. in terms of what we think is a good idea for algorithms or use cases of AI in healthcare, I don't think I want to be in a position where Bunker Hill is deciding which algorithms are valuable and which ones are not. We don't want to be the gatekeepers or decision makers, or even give a sense that we govern what science should be done or what research should be done in this field, or even how research should be done in this field. We just care to make things go faster. AI in medical imaging, or AI in healthcare more broadly, is a medical device, but it is also software. I think it will be really underwhelming for the field if the slowness of the medical device industry or the pharma industry sort of seeps into software. Um, and so the way we have structured our company, the way we've structured our consortium, is that us as a company never needs to make a decision about which algorithms are being validated or being trained. We just let the community decide, which is why when an AI researcher approaches us, we connect them with hospitals in our network, and the hospitals are the ones to decide whether they are excited about the potential of the algorithm or not. That way, at least it's many people's votes as opposed to just Bunker Hill's vote or my vote. And that way, not only is our system more scalable, but at the same time, we are not viewed as a gatekeeper for AI in healthcare. For the second question that you had, is how we get in touch with the researchers. Today, it's mostly word of mouth. We have rarely met a researcher working in this field who didn't like the idea of getting their algorithms into the clinic. And so as a result, we have had good success there. I mean, it's just researchers want to do science, they want to do machine learning, they want to do clinical research. They don't want to do red tape or agreements or committees or regulatory bodies. That's our job. And so we take on all of that. So it's a really good compliment.
It's amazing. So more in the process of kind of getting in touch with people, for example, like how you got in touch with Kurt, or how you're contacting hospitals. What are some tips you would have for reaching out to potential mentors if you want to work on a project?
Honestly, I do not know why people respond to cold emails. That's one of the things I'm really, again, grateful for. Like, there are folks in this world who take chances on people and do things that they don't need to do. And so I guess like my only recommendation there would be talk about something that's exciting, potentially to them, and to see if they respond.
Yeah, and another question. So are there any, specific algorithms that are currently in the process that you're kind of excited about, or, yeah.
Yeah, there are several algorithms. It's hard to pick a favorite of some kind, but I'll talk about a couple of use cases. The first one I've already went over. I'm a big fan of the Stanford algorithm that finds patients with cardiovascular risk when they're not aware. We've actually sat on calls where hospitals have called up those patients who did not know that they had a heart disease, but now because of this algorithm, they are aware of it. And they didn't come to the hospital to get checked for cardiovascular risk. They just came to the hospital for some other reason. And to be caught with this kind of disease, we've had many patients who have just responded with so much gratitude, with just like, wow, this is, thank you for notifying me. This is, they need to implement lifestyle changes. They want to get started on the preventive medications that could lower the risk of heart attack by 15-20%. And it's just really exciting. The other type of algorithms that I'm particularly excited about are ones that do things that humans or physicians being humans cannot do. For example, there is a researcher out of UCSF who is working on an algorithm to increase access to breast MRI for patients. So today, when breast MRIs is administered, yeah, the women typically needs to be injected with this dye, contrast injection, which then highlights the parts that they're interested in. But that contrast dye, that contrast injection, is a contraindication for several women, especially pregnant women. So this limits who can get a breast MRI versus who cannot. And so what this researcher at UCSF is doing is, can you take an MRI without that contrast and simulate what contrast looks like on that MRI, which is just super cool. Like, it's not something humans could do, but if, you know, an AI could do this, then that's just wonderful.
Really cool. Yeah, more on kind of the area of like rolling out these algorithms. What other areas do you see intersecting with maybe AI and healthcare, or what other parallels do you see with technologies, other technologies that are being rolled out with AI?
In the domain of healthcare, it's like asking, how can internet impact us, or how can sort of software impact us? It's just any form of data AI can help us extract insights from. And the challenges are not about, hey, is AI something that us as a community should invest into? The question is a lot more around, how do we actually make sure that, one, these tools do make it to clinical practice, two, that they are presented in a workflow and in a way that does not overwhelm physicians making the clinical decisions. And I guess three, in a way that is just really exciting and sort of encouraging for the broader community. I don't think that we want to live in a world where it moves so slowly that people just get exhausted and burnt out from trying to get these tools into practice.
Yeah, and kind of back to the origins of Bunkerhill Health. So how long did it take to kind of push out an MVP? And how big was the founding team involved?
Gosh, this is where I don't have a good answer, because it was a pretty blurry experience. It was just my co-founder and I for quite a few years. I would say it probably took us 2.5 to 3 years almost to go from the first time we realized that this was a problem, to actually seeing some kind of sort of a validation of our solution. So that included all the way from, hey, we tried getting these tools into practice, and under the status quo, we understood what the problems were. We understood sort of what a potential solution could be. We cold emailed tens of hospitals, got them all interested, and then got some validation that this type of infrastructure could actually accelerate the adoption of AI in healthcare. And so I would say that probably took around 2.5 to 3 years, much longer than any of us would have liked. And honestly, if I knew that, I probably would have not started. And yeah, back then it was just my co-founder and I. Now we are a team of 28 folks.
Wow. So looking to the future of Bunker Hill, what's your current focus kind of regarding the streamlining system? And then what are you looking forward to doing within that streamlining system?
Um, I think there are a lot of assumptions that we need to challenge. The world that I would like to live in involves one where you can go from an idea to something that is used in clinical practice within a month. That means that you not only are able to build a proof of concept algorithm, but also get it validated, also go through regulatory clearances, and also have it be such that it's distributed across clinical practice in some capacity. That is not possible today, but I think that there are a few assumptions that we make today that do not need to be made, or we should challenge why it should take that long. And that's so I want to move towards that world, and not just for AI in radiology, but AI in pathology, AI in cardiology, AI in genomics, just every form of application of AI in every specialty of healthcare.
Yeah, and kind of more on those assumptions, like Bunkerhill Health is definitely helping the health industry. But are there any other scenarios that you could picture in terms of like other industries, or do you ever like see yourself expanding to other industries?
No, healthcare is pretty interesting. I don't know. I think healthcare is a complex and confusing enough industry where I don't think I will live long enough to expand to other industries.
Totally. Let's see. Would you have any advice for students kind of interested in also pursuing this area that you've worked so much in like AI and healthcare?
Um, my advice would be more generic or for more generic purposes. What really worked for me was I really spent 2.5 years well, almost 2 years at Stanford, not taking any class besides research units and just working on whatever interested me. It was like a dream for me that I just spent that much time, um, not encumbered by any assignments, any sort of finals or projects, just stuff that I wanted to do. What that really allowed me to do is pursue my curiosity and really just there was no other excuse. Like I could not make up anything to not pursue what I was interested in. And that's what led to this. And so if my sort of more generic advice here is just try to put yourself in a situation where you can follow your curiosity as much as possible. Don't chase vanity metrics like GPA, number of classes. Don't try to flaunt how difficult of a course load you can take that accomplishes nothing.
Very fair. I guess kind of more on the current state of Bunkerhill Health. What are the next steps? Like, what are you most excited about right now? Is there any projects that you're working on or?
So we have evolved in our vision somewhat substantially, where previously we were proof of concept algorithm to clinical practice. Now we want to do idea to clinical practice. So what this also means is going from idea to proof of concept. What I realized pretty uniquely at Stanford is that you have physicians and computer science folks right next to each other, which is why Stanford AIMI is a very unique organization. And what that allows for is physicians who have the clinical expertise to work very closely with the computer science folks who have machine learning expertise. And that allows for algorithms to be created. But if you look at other institutions, like even pick, some of the very big names that everyone must be familiar with, they might have great physicians, but they might not necessarily have a computer science school right next door to them. So what this means is that the physicians there who might have ideas for applications of AI in healthcare can't go from an idea to a proof of concept algorithm. And we want to change that substantially. So based on what OpenAI showed everyone, could we create a foundation model for AI in imaging and in the future AI for healthcare, where that can be used as a Lego block for physicians to build models on top of. So rather than a physician having to work with someone like me or having to sort of invest effort into finding a computer science person to build a model for them, could they just go on to a no-code GUI where they could just build an algorithm there? And could that potentially expand who can go from idea to proof of concept algorithm as quickly as possible? So that's an initiative that I'm super excited by, and something that we feel like we're pretty uniquely posed to do as well.
Yeah. And within that process of kind of growing towards that vision, what's been some of the biggest challenges you've faced and how have you addressed that?
Oh, it's an open research question. I think one of my biggest sort of initial concerns was in order to build a foundation model, you need a ton of data, obviously. And I was skeptical that hospitals would be willing to share data to that extent all at once. I was pleasantly surprised. I was expecting to be laughed out of the rooms, but I was pleasantly surprised. And we now have a data set in sort of the tens of millions of scans with over petabytes of data that we actually believe that we have a decent shot at building such a foundation model. But the questions that are now upon us are the ones that are very fun. It's how do you actually go about building one? How do you go about validating one, such an algorithm? And everything gets challenged. The FDA assumptions get challenged because of such a foundation model. The validation assumptions get challenged. And so it could really mean that that's where, if you'd asked me this, like the previous question of like, what's next, I would probably have not said 1 month, maybe a year ago. I would have probably said 6 to 9 months. But now I actually think that based on this potential route, we could see a lot of assumptions get challenged, which I'm very excited by.
Yeah, well, thank you so much for talking to us. It's been incredibly insightful, and we've learned so much about AI and healthcare through your career story, just hearing about how Bunkerhill Health came about. So on behalf of everyone here, thank you so much. And yeah, and your talk has definitely impacted how we view and see, our futures and like what we want to pursue.
Yeah,
Thank
and we
you.
also want to thank all the participants for their time and for asking such thoughtful questions, which really have helped keep this webinar educational for everyone. And finally, thank you to AIMI for planning this event and making this all possible. Episode 6 will be on Monday, November 4th. So please see the Zoom chat for the registration link. And thank you all again.